Hello student, today we are going to study the interquartile range that is used in data mining for the defining the range of the distribution of the variables density with data with variable density. In the interquartile range, it's the range which where there are five parameters which are used to define the range. They are the maximum, minimum, Q1, Q2 and Q3. Then these quartiles, the Q1, Q2, and Q3 stands for the first quartile, second quartile, and third quartile. The minimum, first quartile, second quartile, third quartile, and five quartile stands for the 5 point summary of the particular distribution. It can be defined as also as the interquartile range, which is equals to Q3 minus Q1, and it the box plot, yeah, box whisk plot are all the same name which are used for describing the range of distribution of variable size data. Here Q1 is the first quartile, Q2 the median value in the set, and Q3 is the third quartile and quartile. Then actually before defining the range, uh, we set all the elements into increasing order. After setting up all the elements in increasing order, we find out the median of this element. The median of this element can be defined as for the odd number of case, then that would be equals to that will be equals to n plus 1 by 2, where n is the number of data element. So in case of odd number of element, the q2 or median, where q2 or median is equals to n plus 1 by 2, and in case of even, the median would be defined by the number and two numbers that are two numbers uh, that are that lies in between the set. As the number is even, so there would be two number in between, and the average of these two number would be considered as the median or q2 for that. For example, if here the number 134556711 is already arranged in ascending order, then here their number of the element is equals to 8. So the the median would be the average of the two intermediate, the mean number that are two number there are middle range, that is the fourth and the fifth, as element are 8 divided by 4, 8. So two median element. In case of even number, so 5, so number would be q it equals to average of the middle is the average of the two middle values. uh, Sorry, the q2 would be equals to the 5 plus 5 divided by 2, that would be equal to 5. So in case of the first would be the range partition would be the 1 3 4 5, and the second would be 5 6 7 11. So after partitioning the array in two parts, the across median, then the first quartile is the median of the first partition, and the third quartile is the median of the second partition. So the median of the first partition, as the number is even, would be equals to 3 plus 4 divided by 2, as 1 3 among 4 1 3 4 5, there are two number 3 and 4 which could be the mean element. So the average of that would be as is taken 3 plus 4 divided by 2, that's equals to 3.5. So here q1 is equal to 3.5. Similarly, the median for the right side 5 6 7 11, the median would be 6 plus 7 divided by 2, that the q3 would be 6.5. So the interquartile range equals to q3 minus q1, that would be equals to 6.5 minus 3.5, that's equals to 3. Now the box is the graphical representation of this distribution. A box and the whisker plots, also called a box plot, display the 5-number summary of the set of data. The 5-number summary is the minimum first quartile, median, third quartile, and maximum. In a box plot, we draw a box from the first quartile to the third quartile. Its length equals to interquartile range. A vertical line goes through the box at the median. The whisker go from each quartile to the minimum or to the maximum. So here there is a diagram. Here lower quartile is Q1, median is Q2, upper quartile is Q3, and the leftmost is the lowest or minimum value, and the rightmost is the highest value. The plot graph box is plotted between the Q1 and Q3, and there is a median line that passes through the Q2. This is called the box and whisker plots. In another example, there is a distribution of the sales of the computers in 12 months. So data is distributed. Yeah, there are 12. So for 12 months each, the distribution or sales of the computers are like this. In this case, first we shall arrange the element in the ascending order. After arranging the element, there are 12 months, so case is even. So the to find out the median, we shall take the average of the two mean elements, 25 plus 39 divided by 2, that equals to 32. So the median would be equals to 32. Now, after dividing, the median is 32, so all the elements which are less than 32 would become the first partition, and element greater than 32 would go to the right side and will be considered as right partition. So the first partition, the number which are less than 32 are 6, 7, 13, 17, 20, and 25. So Q1 is equals to median of these 6 elements. So the number is even. So number would be the average of the min number 13 plus 17 divided by 2. That would be equals to 15. So Q1 equals to 15. Similarly, the number greater than 32 are 39, 41, 43, 49, 51, and 62. Again, the number of element is even. So the median would be equals to 43 plus 49 divided by 2. So 43 plus 49, 92 divided by 2, that's equal to 46. So we have got Q1 equals to 15, Q3 equal to 46, and median was 32. So arranging all these numbers is called the 5-number summary. So 6 the median number, 62 the maximum, 15 first quartile, 32 the median, 46 the third quartile. So this is for the 5 summary distribution of the above data. This is called the box plot summary. So in short, we can say that the box plot summary, whisker plot, yeah, interquartile range are all, or 5-number summary are the range representations for data, which variable data distribution in data mining. That's all about this.